Hello, everyone. Thanks for joining us in another Twitch broadcast, our Let's Talk About Data show. In this show, we talk about databases, we talk about analytics, and all things related to generative AI, your databases as well. Uh, Today, we have another interesting show that's lined up. But before that, let me start by introducing myself. My name is Prasad Matkar. I'm a database specialist solutions architect at AWS, and I help customers in their journey to the cloud. Today, I'm joined with Steve. Steve, do you want to introduce yourself?
Yeah, my name's Steve Abraham. I'm a principal database specialist and work primarily with Aurora-based engines.
Yes, thanks, Steve. So today, like I mentioned, we are going to talk about performance tuning with CloudWatch database insights. So before we start the topic, Steve, we wanted to understand from an RDS and an Aurora perspective, what are the tools that we have for observability of the databases, and how can customers use it?
Yeah, for sure. There are a lot actually. So CloudWatch metrics is a big one. That's been a go-to for a long time. That also, we have CloudWatch logs that allows you to capture the logs from different database instances all in a single place. We also have enhanced monitoring that allows you to view OS level metrics. And also performance insights is something that we've had for a few years now that allows you to look into things like weight types and query performance.
Yep. Yeah, I mean, I echo that. We've had a lot of conversations with customers who generally love, monitoring at each and every level. So, for example, if you want to observe what's happening at the operating system, that's where customers can look at the enhanced monitoring to get a more granular view of it as well. And then the performance insights, which is within the database. What's my query doing? What are the wait events associated? What's holding up a lock in the database. I mean, those are very useful when you try to troubleshoot an incident, as well as you talked about the CloudWatch metrics, where there are a number of metrics that are readily available. The reads IOPS, the write IOPS, the queue depth to understand if there is how are my writes going to the storage as well. So those are very valuable source of information for people who are trying to troubleshoot the incident as well. So yeah, let's focus on our topic today. But before that, let's go into the chat. We have Edie Edits. Hello, Edie is one of our regular viewers. Thanks for joining. Then we have Lydia as well. Lydia is the chat supporter for today, and thanks Lydia for joining. So yeah, let's go back to the main topic, which is like what is CloudWatch database insights, and why is it launched such a big deal for the database professionals?
Yeah, so CloudWatch Database Insights, I think that one of the big things about it is all of these various tools that we were just discussing, CloudWatch metrics, logs, enhanced monitoring, etc. They they're all various different tools that you'd have to go to different places to find. And so one of the things is this brings all of those tools under one umbrella. And
Yeah.
what's more, it also adds additional tools that we'll get into as well. Yeah.
Okay. Yeah, I mean this is very useful because when we try to troubleshoot any performance issue, it becomes at times it becomes very difficult to map you know the the issues that we are seeing at the database and then correlate it with the application around the same time to get an idea about where the performance bottlenecks can be. So I mean, having a single pane where you can observe all of this in an end-to-end workflow would definitely help the customers as well. And then as far as there are certain customers who have different databases as well.
Mhm.
So to have a single pane where you can look at all the databases, group them together, and then have your observable, you can observe them as a group. Uh, it's a very logically nice step for the end customer as well.
Yeah,
So
I was going to say it's a great point you bring up. The other main thing is this being able to look at the fleet view. And you can look at, different engines, you can look at, the fleet as a whole.
Mhm.
And if you have a very large, I work with some customers that they have thousands of instances. And so it would be very difficult to go through them one by one and sort of, you'd have to write some sort of custom tooling otherwise. And database insights allows you to, within the dashboard, get a quick high-level view and then drill in on those individual databases. Sorry, I didn't mean to cut you off there, by the way.
No, that's totally fine. Well, we're looking forward to, and I'm sure you have an interesting demo where you'll actually go into the various screens as well to show us, how to troubleshoot and what are the metrics, or uh, how we can even configure a few of them as well. So that
Yeah.
will be really interesting. So, how does Database Insights build on performance insights to create a complete solution?
Sure. So database insights actually it leverages performance insights. So for
Okay.
example, we talked a little bit about the high level fleet view, but
Mhm.
once you drill down into an individual instance, I think that what you'll find is the view looks very much like what you have come to expect with performance insights. What's more, the APIs are still very performance insights, they're the same commands, et cetera. So there's a lot of continuity in between. We'll say that database insights just layers on and builds on top of performance insights.
Okay. Yeah. Yeah, it will be interesting to observe, how, like you mentioned, as we go deep into each and every level, it actually leverages the performance insights to, gather more information. So, yeah. So Lydia has posted a link about the database insights, so you can, have a more reading on this one as well. And then we have Data Whisperer, who's a regular viewer. He's tuning in from the UK. Thanks for joining. We have Erie Edits as well, joining from LA. And again, thank you for joining, and Lydia as well from the UK. Thank you all. So yeah, let's proceed with our discussion. You mentioned about the fleet monitoring. It sounds a very powerful tool, but can you explain like what it is actually and what problems does it solve?
Yeah, so it allows you to view your entire fleet in one sort of dashboard, a single pane of glass, if you will. And so, as we'll see when we get into the demo in a little bit, there's a honeycomb structure that allows you to see just, like for example, the instances that are running hot, they show up as red, for example. There are events that will show up. So if there are events that are happening with your databases, those will show up categorized. You can filter by, high importance or low. Maybe they're just informational and you can ignore them. And then once you've identified something that requires a little deeper dive, then
Mhm.
you can drill in on that specific instance and then get more into the details about it.
Okay.
So, yeah,
So
it might be powerful. Yeah.
yeah, Steve, just to understand, you mentioned about the fleet. Now, a fleet can be combination of multiple databases. So I can have a Postgres, a SQL Server, and an Oracle clubbed together in a fleet, because that serves a common application. So it can be across.
So yeah, so there is a default sort of dashboard that shows
Uh-huh.
everything, and then you
Okay.
can, subdivide that into, maybe by application, maybe by engine,
Okay.
however it is that you wanted to categorize those.
Okay. Yeah. Then that makes sense because you can categorize it. If you have an application and an end-to-end like 10 databases, but of different types supporting, you can logically group them together. And then I think you can have like two different groups, one for the production and one for your lower environments as well.
Yes.
On the similar lines.
Yep. Yeah,
Okay.
you can carve them up however you want.
Okay. Yeah, that's good. I think I've read a little bit about the CloudWatch database insights. So lock analysis is a new capability. So how does it help teams to troubleshoot like blocking issues or deadlock issues?
Yeah. So oftentimes, I mean, if you're working with databases on any level, performance is usually what is the concern for most people. Databases, if they're doing well, nobody even thinks about them, right? They're
Yep.
just constantly serving data. And so it's only when there's a problem that you want to look into it. And oftentimes, especially in relational databases,
Mhm.
find where you have to acquire locks, we find that there are blocking chains, so to speak. So in other words, a given process will take a lock on an object. Other
Yep.
processes queue up behind that. And so traditionally, one would have to write a query to do that and then log into the instance, run that query, and then that would return back that locking chain. With database insights, we check for that on a periodic basis. I think it's once every 15 seconds. And so then we capture what that blocking chain is, and then you can view, as we'll see in the demo in a little bit, you can view the actual blocking chain and identify what the lead blocker is. And then from there, you can take steps to, figure out why it's blocking, what can be done, to
Okay.
prevent. Yeah.
And can we have customized, codes or queries as a part and integrated with the database insights as well? Like say, for example, like you mentioned, 10 seconds. If I have a requirement where I need to check for resources after every 5 seconds, can I tweak it a bit, or can I have my customized metrics as well included in the database insights?
You can refresh the screen at various intervals, and you can. I mean, one of the things about CloudWatch metrics itself is that you can create custom CloudWatch metrics. And so if there are custom CloudWatch metrics, yeah, I think that you should incorporate that.
Okay. Yeah. Thank you. Let's look at the chat. So there's a question from Data Whisperer. Is it just for operational databases, or does it include like the OLAP databases like the Redshift as well within the Insight feature?
Yeah, so today it's just the relational databases. It's like your Auroras, your MySQL, Oracle SQL Server. Yeah.
Okay. Sure, thank you. And another question about chance performance insights in November.
I think that maybe what he's getting at is the change, and so that is something I think it's very important to note here. So performance insights as a tool will be deprecated at the end of November, and it will be replaced by CloudWatch database insights. So the APIs will still look pretty much the same, but the main difference is that if you today you're running Performance Insights Standard, the free version, then you will automatically go over to Database Insights Standard, which is also the free version. That's a 7-day retention period, and that won't change. Now, as you probably know, Performance Insights today offers a paid version with a variable retention period, right, up to 24 months. Database Insights, the limit is now 15 months, and right now it will be fixed at 15 months for amount of retention. Now, the pricing with Performance Insights is tied to that retention. It's no longer tied to the retention with Database Insights. So that's all to say that there is a shift from Performance Insights into Database Insights. And so that will officially fully happen on November 30th. However, both exist today. So today you can work with both. You can migrate today with both. And migration, by the way, is very simple. It requires no downtime. It's simply a matter of enabling Database Insights for your particular instances today.
Okay. Yep. That's good to know. Yep. Thanks. Let's take another question. Is this able to work with cross-region Aurora clusters as well?
So let's say that you have a global database, right, that spans 2 regions. Then you absolutely will have this in both regions. You can set it up for regions, but there's nothing that sort of is unique, I guess, to the global database piece. So it would just be a matter of having Database Insights running on the instances in each region.
Okay. Yep. Thank you. So now let's look at the granular level. What is the execution plan capture in the database insights, and how does it differ from the traditional query analysis that we do?
Yeah, normally, if you were running a workload, you identify there's a problem, you want to drill in on it and figure out what's going on, you might explain plan, right?
Yep.
With this, we are proactively capturing the execution plans and saving them for you. So again, a big part of this, traditionally, a lot of these activities, you would have to connect to the database itself and then run some type of query or
Yes.
to get it back. This allows you from a web browser to just view what the plan is. And so what you'll see, in our demo later is that, for a lot of the queries, we'll capture plans and even plan versions. So you can look at, how a plan has changed over time, et cetera. And that might help to identify, say, plan regression, for example. So it's a little more robust than, sort of the spot check where one would normally connect to the database and, pull a execution plan at that moment.
Okay. Yeah. I think there's a similar question. How do we identify where which query execution is taking longer, like slow DB queries?
So we actually do capture slow queries. I
Mhm.
mean, so some of these, like for example, the slow query capture feature requires you to, make some changes to your parameter groups because for most engines that's disabled because it does add some incremental overhead. But if you do have it enabled, then yes, it is captured, and then that allows you to identify not only, and we'll see this in the demo, not only can you see which queries are taking longer, but for the ones that are taking longer, what percentage of the overall taking longer time, for lack of a better way to put it, it's taking. So yeah, we'll get into that in a little more detail, but absolutely, that's also incorporated into this.
Okay. Yep. So now let's look at, you can you explain like performance analysis, which is on demand, and when should teams be using it?
Yes, sure. So performance analysis. So if you open up the dashboard, you see
Mhm.
that there's a hot instance, you drill in on the instance, and you look at what's happening, say, for the last 30 minutes, and you see a spike, and you say,
Okay.
wow, what's happening here? Let's really examine this. You can highlight that and then zoom in and then have it create a performance analysis report. And that's where we will, Database Insights will generate an actual report that tells you what the leading weight types were. It provides you with a link to the documentation that explains what that weight type is. And sometimes it might even provide some recommendations as to what you can do to address it, though the documentation is usually the place that will tell you how to address it. It also allows you can save these reports. So by default, it creates a report and saves it. So if you wanted to reference them over time, maybe go back and look at them later, that's something that you could do.
Okay. I mean, so using the UI, we could just zoom into the problem, when we've seen the spike, and then for that time period is when we'll have a detailed report, an analysis report, indicating like what may be the problem at that point, what are the wait events, what were the queries involved, if there was a lock. Does it give us an idea about even the application side, or like if there was any, or even the storage, if there was anything related to the storage as well at that time?
So it depends. It depends on what type of problem that you run into. But the
Yeah.
performance analysis, it will gather all, we'll say, relevant metrics.
Okay.
Do sort of a thorough analysis of that particular time slice that you've
Okay.
selected.
Mhm. And is there a functionality where we can compare a good period and a period like where we've seen the spike, just to see like how do the numbers vary as well? Can we compare like two different time frames as well?
So that's something that's pretty easy to do just looking at the
Okay.
dashboard itself, because you can specify the time period for how long you want to look. So
Okay.
for, say, if the issue was happening at 2 o'clock in the morning, and that's when you had a problem, but it was good at 1 o'clock and at 3 o'clock, then you can, select those different areas and zoom in and create, say, a performance analysis on the good times as well.
Okay. Yeah.
Yeah.
I'm specifically much relating to the scenario where we've seen query plans flip at times. So if I have a process that runs once a day, yesterday it was running fine, and today it's taking a little longer. Can I compare that time period versus this and identify, okay, the plan has flipped, and additionally, it's doing, earlier it was using an index, today it's doing a fast, like a full scan of the table. Will the report provide like those details as well?
I don't remember if the report specifically does, but what you can do is if you select that time period
Mhm.
and then look at the plans for that given query in that time period, you'll see
Yep.
what the plan was that was used during that time period, and then compare that to what the plan was for the previous time period, the good versus the bad.
Yep. Okay. Let me take a few questions. So, how does this play along with the native DB insights we generally get from, say, Oracle DB?
So I'll admit Oracle is probably the engine I'm least familiar with, but I kind of I guess I gather from the nature of the question, that Oracle provides its own performance metrics, and does that somehow impact or otherwise interact with database insights? Is that
I think the question is like more related to, there are tools in which you can monitor the query performance at the granular level. So, for example, the OEM. Is the database insights like the CloudWatch DB insights very similar to the native tools that are provided? I think that was the question. I
Okay.
mean, when we look at the query details, say for example, at the most granular detail, I mean, the wait events would be very much similar. Like, I mean, exactly the similar to what we would see in the native tools as well, or running through the query as well.
Yeah, and I'll say this too, that, like for example, I work a lot with Aurora MySQL, and so
Uh-huh.
for schema in there, we actually leverage a lot of the metrics out of that in order to build the data that you would see in the dashboard and in the metrics here. So
Yep.
I personally can't speak directly to Oracle, though I suspect that it's probably leveraging some of those native functionalities.
Yep. And let's take one more question out here. So you mentioned about, like, okay, this question is more about the modification. Will modifications to investigation params, say, for example, enabling, disabling slow query analysis require any downtime?
So that's going to depend on the engine itself.
Hmm.
So the engine and the parameter, because each engine implements this differently. And so, I mean, the easiest way to know is if you go into the parameter group itself and you go to edit it, and then it will say directly to the right of the parameter, whether it's static or dynamic. If it's dynamic, it means it will apply immediately and requires no downtime. If it says static, that would indicate you'll need to reboot in order for that parameter to change.
Okay. Yep. Yep. Thank you. And yep. So now we have another observability tool through which you can do the CloudWatch application signals as well. So I mean, the integration with CloudWatch application signals. Can you explain like how correlating database events with the application code? How does it work with the database insights as well?
Yeah. So with application signals, it allows you to instrument your application such
Mhm.
that during certain spans of code in your application, you're recording, how long it takes for a certain span of code to run, for example. And so that's a setup that you would do, sort of outside of database insights. But if you do that, and then you can correlate that with database insights so that, for example, you have an application, it's running, and you see that there is a certain spike in database activity. You can then correlate that spike in database activity to a particular span of application code. And so that will make it a lot easier for you to drill directly into the application and figure out, what changes might need to happen at the application layer as well.
Okay. So I mean, it helps us end to end troubleshoot it back to the application if there was an issue at the application end as well. So would the database, would the CloudWatch, the database insight screen would point out an end to end saying that you had a spike at the database at this point in time, and around the same time you've seen some parameters at the application server and also performing there's a spike observed at the application server and as well. So I mean, would we be able to correlate in that manner?
Yes, you can, right from the screen that shows you, the weight types and, the general performance for the database. There is a section called calling services. And if you click on that, that will allow
Okay.
you to see exactly what's going on application wise during that time.
Okay. Nice. Yeah, we have a lot of questions from the audience. Let's take a few of them now. Are there are I mean, are there documentations about parameters we need to change uh, to deep the performance logs and analysis?
There
Uh,
is documentation. It
okay.
depends on the engine as to which parameters in particular. I
Okay.
believe that the database insights documentation does outline some or most of that at least. Um, but there are similar, for example, this capturing slow queries, right?
Mhm.
It's obviously a different parameter to change for MySQL versus say Postgres, but that I do think I'd have to double check, but I do think that most of that is in the database insights documentation.
Okay. And we have another question. Is it possible to integrate it with a Lambda via an event bridge, etc., if needed to take action, say, create an index, etc.?
That's an interesting idea. I don't know that there's anything native to it. Now, I will say this, that I mean, if you were being extra creative, you could have, say, a polling, Lambda,
Mhm.
maybe via EventBridge with a cron type of setup that is accessing the API to look for, given execution plans or wait types or whatever you have. And then if I think it seems a little risky to do on a production system, but if you wanted to at least try it out in some other system where you would apply, say, in index or something like that, yeah, I think that technically you could do that, but it's not really a sort of a native built-in feature.
Okay. Yeah. And I think you covered this again. Like, is there a way in which you can integrate the database insights with the notification systems?
So what you can do is with CloudWatch metrics in general. So
Mhm.
I gather that the question is that you want to be notified if a certain metric or threshold is breached.
Yeah.
And so that I think would just fall back to, CloudWatch metrics itself, where you can set an alert for a certain threshold for a certain metric that will be breached. The thing about database insights is it takes, I mean, we still have, for example, CloudWatch metrics. That still is a tool, but CloudWatch database insights, what it does is it takes all of these tools and puts them under one umbrella. So
Okay.
that would be the way that I would approach that.
Okay. Yeah. Thank you. So yeah, now let's look at the real world scenarios where these database insights can all come together to solve performance issues.
Yeah. Yeah. So, I mean, imagine that you had, say, like an e-commerce
Mhm.
application, right? So you obviously have the application, it's running, it's connected to the database, and then you hear from your users, or maybe someone else has told you that, the application is slowed down in the checkout process, for example. And so you say, well, that's interesting. Let's look into it. Now, if you've instrumented the application such that it's, capturing those spans of code execution that I was talking about previously, then you could go into database insights. And first of all, you know which databases that you have that belong to that application, right? And you know that because you've grouped them inside of the main dashboard of database insights. So you can, at a quick glance, look at those and say, are any of these databases related to this application hot? Are any of them red? So instantly you can see that. And let's say that you do see one that's red. You can drill in on that particular one, and then you look and say, oh, I see that, the weight types have increased, or the total weights, I should say, have increased during the last few minutes. So what is causing that? And from there, you can say, well, the weight type is, I don't know, it's maybe your IO bound, for example.
Mhm.
And then you can also see what the top queries are that are causing those weights. And so you might already know, what's going on just based on your general application knowledge, but maybe not. And that's where you would look under the calling services to correlate what's happening, application wise with that database, those database calls as well. And so at this point, what you've narrowed it down to, you've taken this broad question of we're having a slowdown during our checkout process and narrowed it down to this is the segment of code in the application where it's happening. These are the queries that are causing it. This is the weight type that those queries are waiting on. And so, and then we can even say, and these are the query plans, we can look and say, are the queries being blocked by, by doing block analysis. I mean, we can even do an in-depth performance analysis report. So a lot of tools to really laser focus and pinpoint what's going on with the database and then address it.
Yeah, I mean that's the most granular view, like going from each layer to another, and it could be like in the scenario that you stated. It could be a multiple or a lot of connections being initiated from one of the servers. As we go into each and every layer, that's when we'll come to know, where are these sessions being initiated from as well, which are increasing the load on the
Yeah,
system.
for sure. Yeah, that's another thing too that we'll see in a little bit, that you can actually narrow it down to which instances are connecting to the
Mhm.
database, contributing load, which users are contributing to the load. There are a lot of different dimensions that you can look at to help you narrow down where the load is coming from.
Yeah, that's great. So for teams who are already using performance insights at the moment, what is the immediate benefits that they will see by using the CloudWatch database insights?
I think that maybe the biggest immediate benefit is the fleet level view, especially if you have any sizable number of databases. I think that that's a really powerful feature that you can just at a glance. Beyond that, if you're just maybe you've got a smaller fleet, or it's more important to you that the individual um, the individual view. I think that the lock analysis, the plan capture, I think those are very powerful. Um, and I think too that just having all of these tools under one umbrella and not having to go to 3 or 4 different locations to try and cobble together the whole picture. I think that that is really powerful.
That's good to know. So yeah, now let's head over to the most interesting part, the fun part of the show, where we do the live demos. And before we go on to the demo, what are the performance tuning scenarios that Steve will be showing us in this demo, and what are the main features of the CloudWatch database insights that the viewers should be more glued on to, the unique values associated.
Sure. So what we're going to do is start with just the dashboard at a high level. I
Mhm.
don't have a huge fleet. I've only got a few, but we'll take a look and see what the load looks like, and then we'll drill in and walk through each of the various components that we can
Yep, sounds good.
identify. All right. Well, did you want to let's bring up my screen, I guess.
Yep.
All right, so right here, this is the Database Insights landing page. I mean, to get here, we'll just go from the top. To get here, we just go to CloudWatch, and then we can scroll down under Database Insights, and then this will show me the entire fleet view. Now, this right here is where you could, I don't have a big enough fleet really to, put a bunch of properties and tags to filter them, but you can save a filter as a fleet. And this is what we were talking about. If you had, say, an application that you wanted to, you had a bunch of databases that go with it, you could tag them appropriately and create a fleet, as it were.
Yeah.
But this is just my overall fleet dashboard, and I'll close this just so we can see better. And this right here, this honeycomb, this allows you to see at a high level, what's going on. So these 4 blue ones, they're pretty much idle. I don't have any that are marked as red, as high, one for warning. And so that's this APG, so Aurora Postgres Virginia Node 1 instance. And I can see that the database load utilization is quite high, right? And I can see, what the engine type is and whether it's serverless or provisioned. So I've got a decent view, and I can also see over here top 10 database instance load by utilization. Again, for all of these, my 6 databases, far and away, we can see this is our troublemaker. And this is obviously a bit exaggerated because this is just a demo. You would probably see a little more distribution across your instances in your own fleet. But this here would be if I've not done the instrumentation for the application here, but if I had, it would show up right here. Over here are the events. And you can see right now I've got 7 low severity events. When I click on this, it filters by low, and I can just see, what are some of these events. These are mostly just informational events that are happening, so I can ignore those. That's not really pertinent to what I'm looking at. And I can also see right here the top 10 instances per metric, and you can select 2 different metrics here so that you can compare them, side by side. Let's say I want to look at read IO, next to CPU, for example. And then databases too. This also just gives you, a real, in case you're having trouble identifying which one was giving you the biggest problem, sorting by database load here, we can obviously see that this is our troublemaker. So now I'm going to drill in on this particular database. And right now I'm just running a synthetic PG bench workload on
Mhm.
this. So but it is, I've crafted it in such a way that it will allow us to show some of the features here. But let's just kind of walk through from the top to the bottom. I do like this pin to the top. This allows you to, pin this database load to the top. This right here is going to give you an overall view of how the database instance is performing. You can see this dashed line right here. This is, you'll notice that it's at about 32.
Mhm.
32 is how many vCPUs I have on this instance, because I'm running an R8G8X large. So this right here, just as a broad metric, if your workload is exceeding this, you're probably under provisioned. If it's under it, then you might be over provisioned. It's a very broad statement. It's not 100% true, but it's a good starting point. And you can see as I mouse over this that it's showing, the different, metrics for each of these bars. Let's zoom in to just the last 30 minutes. This is a little bit more, you can see that, we've got some bigger chunks like this brownish kind of color right here. We're currently sliced by weights. In weights, this is usually where I look first because this is what the database is waiting on, right? And so in this case, it's lock transaction ID. And so now if I were to, we talked about the analyzing performance. Let's just say that I wanted to select, from here to here. And then I wanted to just zoom in and click Analyze Performance. I can give it an optional name, but we'll say Create Performance Report. Now that will happen in the background, but in the meantime, while that's going on, we're going to go back to our database load analysis in the top SQL. And what we can see here is this update PG bench. This query right here is the one that's causing most of our waits. Oh, and it looks like our report's done. Let's go over here. We'll take a look at this really quick. So during that analysis period, we can see here's the database name, the engine, the time it was created, the start time, end time, and we can see that the main thing that's happening is unusually high database load, right? We've got the entire analysis period, or just in this case, in the one insight. And then as we scroll down, we can see it's saying we've got a high database load, which no kidding, we can see that. And then it was the most impactful wait during that time range. Mm-hmm. And then click on View Troubleshooting Doc. This will give us some ideas of why that might be happening. So this is pretty straightforward, and this is actually by design. This particular workload, let me go back here.
Yep.
Particular workload. I'm sorry, Prasad, did you have a question?
No, I think, yeah. Let's go back to that main screen. I think there was a question related to the workload that you had mentioned about the vCPUs, and there were sections and the query patterns that were going above the vCPUs. Yeah. So the question was, can you elaborate a bit further about under provisioning and over provisioning, the rule of thumb that you just showed?
Yeah. So what this is showing is the average active sessions. And a session is essentially a query or a command that's running at a given point in time. So mm-hmm. if you have 32 vCPUs and you are running across, you've got more than that running at that particular time, then somebody's going to end up waiting, right? And so what this is showing is that our waits are in fact exceeding what that machine can handle. Now, the waits, we're not always waiting on CPU. In fact, right here, you can see the green represents the CPU and it's relatively low. We're mostly waiting on locks. And so it's not always right on, but I would say this, if you look at this graph and your workload is say half of the vCPUs all of the time, then you probably don't need all of those vCPUs. You could probably safely move down a size in instance, and that would cut your CPUs in half, and you would still potentially be in a good place. Now I say that with the caveat that does not take into consideration things like your buffer pool, right? And so sometimes depending on the database and the application, you need a larger instance that may be over provisioned CPU wise, just so that you have a larger buffer pool based on what the workload looks like. And there are other considerations, but I would say just as a broad stroke, as a first blush, when you look at it, that would be something that would at least merit further investigation. Likewise, this workload is intentionally designed to really push the database. But let's say that most of the time you were under the bar and then occasionally there were spikes above it. That would not necessarily mean that you are under provisioned. It means that you're pushing the database for a period. I wouldn't necessarily jump it up a step just based on that. But again, it's just meant as sort of a nice broad gauge to look into, how you're sized and how you're performing.
Yep.
All right. So we just did the performance analysis. I like to zoom in. The 30 minutes is usually, at least for me, it's the most recent. But we went through database load analysis and top SQL. We see this, and then this right here. Let's take a look at lock analysis, right?
Okay.
So in here, what we see, and this is no surprise because this was intentionally written this way to generate locks, but we can see that this session ID is generating this chain of all of these locks, right? So this tells me we've got a big problem with this update PG bench accounts set a balance right here. So this is something that warrants, further drilling into. You can also, there are different snapshot windows in here. So you can select which one, and it'll show you too where those locks line up here. So for example, right now we're looking at the lock tree for this window that corresponds to this time here, where we can also see that, lock transaction ID is our #1 weight. So this, Database Insights allows you to bring all of these things together and correlate all these things into a single place. We can also, as we're going through, look at what our top weights are system-wide. So again, not surprised, transaction ID, top hosts. I'm running this all from a single EC2 instance, but in a real application, you would likely have multiple hosts here. And so you could see if there was, say, a rogue host, you want a rogue client host, top users. So I have created a few different users. I've got one user that's running reports, one that's uploading some batches, and another one that is just a web user. And you can see too, you can see the difference in their workload patterns, right? So the report user is doing mostly selects, and so we're mostly CPU bound here. Whereas the web user, there's a lot of updates happening, and so that's providing a lot of the locks on the transaction IDs. The top session types, this too will tell you, like, for example, auto vacuum it runs in the background, but it's really, it's mostly, my application that's causing the weight types. Top applications. This is another thing too, is, depending on, if you specify in your connection string which application, then you can see which application is providing the most weights. And then of course, top databases, and I just have the one DVI demo database that I'm using. So that's mostly the tools under load analysis, but then I can also move over to database telemetry. This is something that you're probably familiar with. By the way, this I'm sure looks very familiar to those of you that have used Performance Insights. This database telemetry, also same sort of thing. You can create widgets in here too, which I think is really great. So like buffer pool, and then I can scroll down here and I can select where is it? Buffer cache hit ratio. There we go. And so, I can add, my own metrics here. You can see we're 100% in memory, so we are definitely not IO bound, but that wasn't part of my initial dashboard. But maybe I don't need that anymore. I can reset the dashboard. We talked about logs, right? So these are your actual database logs. And so in my case, I've configured this instance to send all of my logs to CloudWatch logs, which I would say is generally a best practice, especially if you have a significant fleet, just because all of your logs for all of your instances are in one place. It makes them easy to query and to look at. Slow SQL queries. So again, no surprise, we're seeing that this update PG bench query is one of the big ones. Gotta slide this over to see everything that it shows. But the sample count, and then this is about 70%. It's accounting for about 70% of the total, sort of load, as far as slow queries go. And then these are the actual literal queries that correspond to that particular sort of pattern. On the left, you see the pattern. On the right, you see the actual queries. Events, There aren't any significant events that are happening right now. And OS processes, this brings us back to the
And
monitoring, right?
Yep.
And so with this, I mean, you can see, you can sort by, let's see, CPU, who's, the Aurora storage daemon, but then we've got all of these various other processes, which, in Postgres, they map to individual, connections. So you can see what's happening at the performance layer. We've already gone through the performance analysis here where we had our reports. And then if I had instrumented the application, this is where the calling services would show up as well. So let me see, did I miss anything here? We went through load analysis. I think that covers most of what we can see in here.
Yeah. Is there a way in which you can see the query plans as well?
Oh yeah, that's a good point. So in here, top SQL, and so then if we scroll to the right, it should show. I changed my font a little bit for for this broadcast. So I'm not seeing to the right. Normally there's a column on the right, maybe with a smaller resolution, it'll show up that says how many plans there are. But if we select this and then go down here, first of all, you can see this is, the SQL text, this is plans. So in this one, here is the actual plan. It looks like we only have one plan for this query. This is what the plan is. And so you can view it, right here. Let's see about some of these other ones. So there are no plans available for this one. It varies. Not all of these will have plans, but many of them will.
Okay.
The other thing that's interesting too is this PG bench update right here, right? If we scroll down, we obviously have the SQL text, the plans, but the SQL metrics I think is also very important because this ties in the actual SQL metrics to this particular query. So we can see how many calls per second over time. We can see how many rows per second are updated over time. This is the average execution time. So this would be the sum of the execution time for this query divided by how many executions there were. So you can see on average what the execution time is. And it goes on. There are a lot of other metrics down here, but I think that it's really powerful to be able to drill in on the particular metrics for a given query.
And then we talked about, at the application layer as well. We now drill down into the database and each and every parameter. Now, you mentioned about we have a ability where if we have enabled the application signals as well, we can end-to-end, view like at the same time what's happening at the application server as. So if you could go into that screen, just showing the audience.
This is it right here. And
the
so,
calling.
yeah, and so like I said, I didn't have to put together the instrumentation into the application for this, but had I done that, you would see right here what the service is, the operations, and so this is where you would be able to see and correlate to what's going on up here as far as what the application itself is doing. So you have not only this, but even this is very granular and down to specific plans inside the application. But even just at a high level, you can click on top applications, and this information is coming from the connection string. So it would all of this requires well, not all of it, some of it, like this for example, requires you to make some specific though minor changes to the application for it to show up. But you can see here that our web app, the high concurrency locks is the one that is the leader, followed by the medium, and then the various different types. And then so yeah, by application, sometimes you use a different user for different application. Maybe you're running the application on different hosts. So those three, even if you don't do the instrumentation, those three things will at least help you narrow it down to what application and what it's doing.
Yep. That's a very detailed view. It will help the database, the DBAs, as well as even the developers to quickly through a single screen see where the problem is and to dive into it into much granular details to understand what the problem might be. So yeah, let's I think take a couple of questions. So let me bring up this one. This question was related to going forward. Will this be extended to the NoSQL DBs as well?
That's a good question. Honestly, I'm not sure, but it's a good recommendation, and I mean, something we can consider.
Okay. And are there any performance implications of running insights? And if so, can this be turned off?
So actually having database insights enabled, there's, I would say, maybe a negligible amount of overhead. Now, I'll say that with the caveat that you can enable certain, engine specific parameters that will give you, for example, if we were looking at, the top SQL and we're looking at, let me re-authenticate here.
Okay.
If you were looking at the top SQL and you were looking at the query plans,
Mhm.
there are, and this particular one is running on Postgres. There are more details within the query plans that you can get by enabling certain parameters. And, and the more of those things that you enable, that you turn on, the more overhead that provides to the engine. But that's something that's more specific to the engine and an engine specific parameter rather than database insights itself, if that makes sense.
Okay. Yep. And I think this was more specific to the buffer pool, the custom metric that you did add. Is there a rule of thumb for the buffer pool metric?
Yeah, so the buffer pool in relational databases across the board, relational databases, they only ever do operations on pages or blocks that are in memory in the buffer pool. So that's inserts, updates, deletes, selects, etc. And so it's most impactful for selects. So if you have a read heavy workload, the buffer cache hit ratio is the percent of time that when the database engine is looking for a page, that it finds it in memory in that buffer cache. And so the rule of thumb as far as the actual number, I would say should be 99.5 or better. If you had, say, like a 90%, that would be atrocious. I mean, it sounds like an A, but if 10% of the time you're having to pull pages from the disk, given that the disk will be thousands of times slower than memory, that's going to be a significant impact to your workload. And so that's why, in some cases, even if, you're, in this line right here, you might be significantly lower here if
Mhm.
your actual database requires, more memory so that you have that higher buffer cache hit ratio, it might be warranted. If your cache hit ratio is low, I guarantee you're going to see your read IOs increase dramatically, and at least your select queries slow down quite a lot too. So in that case, financially, you might want to say, is it less expensive to have a higher sized instance with more memory, or to pay for the IOs? So, these are always,
Yep.
no solutions, just trade-offs, kind of a consideration.
So, yep, that was a great demo, Steve. It helped us understand a lot of things, how we could use the database insights to have a granular view. So there are a couple of questions. One's about the the median execution time. So can we choose an execution time or a 75th percentile? Can we have like the custom metrics? Say, for example, the slow running query. What might be a slow running in one environment might be different in another. So can we customize those?
So that, I think, would be, you're absolutely right. The metric you want to look at would be like, say, select latency or DML latency, right?
Okay.
And so that would be something where you would create a CloudWatch metrics alert around, right?
Mhm.
Once you, for your application, have defined, that this is, I want my average select latency to be, 2 milliseconds. Then you can create a CloudWatch alert so that on that metric, if it exceeds that for a certain period, then you get alerted. And
Okay.
that would be, yeah. I hope that answers the question.
Yep. And let's take the final question. I know we've just 5 minutes there. So the last one being, does this analysis also help us identify what are the read write profiles in your in the database workload? And would it suggest it's a read heavy workload, or it's read heavy for most of the times? Please provision an additional read replica.
Yeah, so I mean, the way that you would look at that is under this database load analysis. So I mean, you zoom into a given time period, and then you would look at, first of all, if you have a lot of select queries here, that would
Mhm.
be a pretty big giveaway. You can also look into, when you drill into the metrics that we looked at earlier around read IOs, things like that. That would be a great indicator that you should use a read replica.
Yep.
Yeah.
Thank you, Steve. So yeah, Lydia has shared a link about useful blog in the chat. So this is about the real life scenarios. So yeah, so thanks once again, Steve. It was really amazing to have you on the show, and the demo was really good. And thank you to the audience as well for joining us and staying tuned for this show. Again, do tune in next week, where we'll have at the same time, where we'll have another interesting episode where we'll be um, covering all things related to data again, as I mentioned. And again, thank you all for joining the stream, and thank you, Steve, once again.
Yeah, thank you, everybody. I really appreciate it.
Cheers. Thank you. Bye bye.